Hi, my name is Blin and this is my demo video for my project 1 of ECE 561. I'm going to go through my code first, show a little bit of debugging, and then show the board physically as it's running the code. Hope you enjoy. This is the explanation of the code that I wrote for project 1. I'm just going to go through it as it's written, and as I come to different functions, I'll jump down to where they are in the code as they're called. So first off, you start with the include files. They're the standard MSP432 files and the driver lib.h, which has a lot of useful functions that will be used in this project. Next are all my initialization functions. Like I said, I'll go through those as I come to them in the code. Next up, I define a couple global integers. One is my buffer memory start. This is the location where I'm going to start my erase and write of my program. To start off, this is at the 20x20000, which corresponds to bank 1 sector 1 in the MSP432 board, and that's the beginning of where I'm going to start writing and erasing for this project. The next integer I have is a 2 kilobyte step in memory. I'm going to use this to write and then step another 2 kilobytes and write again, as I'll show you later on. Next, I have my current flash sector. This is just the value that corresponds to the flash sector. 0x1 corresponds to sector 1, 0x2 is sector 2, 0x4 is sector 3, and it keeps doubling as you go through the sectors, and I have a algorithm that jumps through those as I want to access each sector in turn. Next, I have an array made up of 2048 locations. This is our 2 kilobyte buffer that we're going to be using to write values into the memory locations. So as you enter the main function, you can see first I stop the watchdog timer. Next, I disable all the interrupts. Then I put the board into active mode, LDO, and VCore 0. I use this because it's one of the more efficient active mode power settings. It allows me to use 1.5 megahertz clock and read and write to the flash memory easily while trying to save a little bit of power. Next, I set the DCO clock to 1.5 megahertz, and then I set my M clock to be referencing the DCO clock with a divider of 1, so that my system clock is just going to be running at 1.5 megahertz. Next up, I do my port initialization. So now I'm going to jump down to the bottom so you can see that function, which is down here. Essentially, what it is we set the direction of pin 1.4 as an input, which is going to be our button, S2. On that same pin, we're going to enable a pull resistor, and we're going to make that resistor a pull-up resistor with these these references on the left. Next, we're going to set the direction of our LEDs. Pin 1.10 is going to be an output. That's going to be a red LED. Pin 2.1 is also an output. That's going to be our green LED. So now I'll jump back up to the code, and then we can see the first thing we're going to do is we're going to turn on the red LED, delay for 1 second, and then turn the LED off. So I'm going to go down and look at my delay function really fast so you can see what that's composed of. You can see I have a delay of 780 milliseconds approximately, and a delay of 1 second approximately. And all these are is for loops that count an appropriate number of times to create that long of the desired delay. So back up to my code. After we turn off the red LED, we're going to set our flash wait state to 2 for bank 0 and 1. This was a standard thing we saw in the examples, so that's why it's in here. Next up, I'm going to populate my buffer array with values of B8. So B8 is the byte that I'm going to be writing to all the memory locations and fill up the entire 128 kilobytes. Next, I start my watchdog timer. This is the initialization you use to set it for 1 second when it's using the 32 kilohertz B clock. Next, I define an integer called sector, which I'm going to use to count through each of my sectors. So as I enter the while loop, I have a for loop with sector equal to 0 all the way up to 32. And what that does is it'll do my erase and write to each of those sectors in turn, and that'll happen about once every minute all the way through each of the 32 sectors. So you can see the first thing I do is the erase and program flash, so I'll jump down to that function, which is right here. You can see it starts by unprotecting the sector that I'm working in, which is bank 1, and my variable of current flash sector is used to denote bank 0, 1, 2, 3, and so on as I call this every time. Next up, I have the erase sector function. This is the standard erasing sector, and it starts at my buffer start, which will erase at that point throughout the rest of that sector. Because that takes almost a second, I'm going to clear my watchdog timer so it doesn't reset. Next up, I'm going to start my write of a 2 kilobyte section. So I start at my buffer memory start, and I'm only going to write 2 kilobytes of that information because it takes almost more than a second to do the 4K all at once. So I'm going to clear my watchdog timer one more time, and then I'm going to increment my buffer memory start by this 2 kilobyte value so that it goes to the next so it passes the 2 kilobytes that I've already written, and then it writes once again with this new buffer memory start the same values over again, so that way I fill up the whole 4 kilobytes of sector 0 or sector 1. And then I protect that sector and it jumps back up to the code. So after I do that, I check to see if my button 2 is pressed, and if I hold it down, it'll stay in this loop and trigger the watchdog timer after a second. So if the button's not pressed, it'll go back, clear the watchdog timer once again, and then delay 780 milliseconds approximately. And this way, I wrote the code so each of my loops takes a little bit less than 2 seconds so that I can go through all 32 sectors in just about exactly 1 minute, which is required by the project. Next step, I start my buffer memory start. I move it through 2 more kilobytes of memory, and then I increment my flash sector to the next sector, and it loops back around and starts the erase and flash process all over again for the next sector. It repeats this 31 times until all 32 sectors have been written, and at that point everything has been written that needs to be written. It'll exit out of this loop, clear the watchdog timer again, and then turn on the green LED, pause 1 second, and turn the green LED off. After this, my buffer memory start reinitializes to the start of bank 1 sector 1, and that's what my flash sector corresponds to, sector 1, and it resets all over again and rewrites everything once again. Okay, so now we're going to go to the debugger so you can see, I can add some breakpoints and go through the memory browser so you can see the memory actually being written to verify that this is what is actually happening. So we let it load. Once it's ready to go, what I'm going to do is I'm going to come down here, and right after my erase program flash, I'm going to add a breakpoint, and so that way we can see what happens after we write each one. So I'm going to go over here, I'm going to type 0x20000. So that's going to show us our beginning of our memory location. And so if I run it, you will see that my code starts up and it writes to B8. And it went all the way through that sector, so you can see if I jump to the next sector, right before it is written, just after, and this is the start of my second sector. So if I jump through my breakpoint one more time, you'll see that it'll write it and then go all the way to the next sector, which is down here. And as you can see, it wrote all the way up to that sector, stopped, and now this is the start of sector 3. And what I'm going to do is I'm going to jump to the end of sector 3 so you can also see that it gets written at that time also. So here's the beginning of sector 4, end of sector 3. When I write it, you see that it gets written right there, all the way to the next sector 4. And my code jumps through each of these sectors, unprotecting, writing, or erasing, then writing, and then reprotecting, so that you can see, and as you can see, it wrote BH to all those values. So now I'm going to go into my function and add a breakpoint on the erasing part, so you can actually see that my code erases what's already here before it writes it. So what I'm going to do is I'm going to go right here to right after the erase sector, add a breakpoint there. I'm going to go back to the beginning of my bank. You can see it's still written. I'm going to restart and I'm going to press go. So you can see it deleted it, stopped at my breakpoint, and if I click next, you can see that it wrote it, went to the next breakpoint. So if I jump ahead to the next sector, you should be able to see that it deleted the next sector as anticipated. I push it again, it writes it just like you'd expect, so that shows that it does delete the sector as I go before it writes to it in the next step of the code. So the last thing I want to show with the debugger is how the value of the pin 1 for the red LED changes as the board initializes and starts up. So I'm going to do this with the first part of the code. So first I created breakpoints at the port initialize, which is right before it turns on the red LED, the delay function, which is after it's been turned on, and then at the wait state call, which is after we turn off the LED. So we'll go over to the register, DIO, PA out, and look at P1 out, which is our red LED. We'll start the debugger. You can see nothing happened yet. We go to the next state, it updated to a 1, which means it's on. We click again, and it updated to a 0, which means it turned off. So you can see that the pin output is working as it shows in the code, and it's being shown here. Next I'll show you what the board is seeing in real time. Okay, so now I'm going to show you what it looks like when the board is turned on. So keep an eye out for the red LED because it's going to come on for 1 second, and then I'm going to start my timer and then explain it. So red LED came on for 1 second. As soon as it turned off, I started my timer, which means the flash memory is starting to be written or erased and written as soon as the red LED turns off. So I started my timer. I'm going to fast forward through this up until a minute so you can see when it finishes flashing and the green LED comes on. So as you can see, it took 1 minute and about 2 seconds for my board to do all of the flashing, writing of the 128 kilobytes, and then the LED turned off and it started the whole process over again. Now to show the watchdog timer, if I push and hold it for 1 second, the red LED comes on for a second, and that indicates the board was reset, and it just keeps doing that 1 second at a time until I let go. And if I let go, the board restarts and starts writing once again. So I'll do it one more time. I hold the LED, or hold the pin down, the LED turns on, and the board resets, just like described in the project.